So I'm Adrian Price-Whelan. I'm one of the 4 organizers, and then we have a bunch of moderators who will also be introducing themselves later on. So this is just the welcome part of the meeting. And so the first thing I want to do is just thank the Flatiron Institute at the Simons Foundation who helped us do a lot of the actual organization of the meeting, setting up AV and things like that. So thank you to the Flatiron Institute. I think this is going to be a really fun week, and I've really been enjoying already watching all of the talks and seeing all the discussion that's happening on Slack. It's already a little overwhelming, but also super fun to see all of that happening. So thank you. Right. So obviously, I think one of the most important things about this meeting is to find out what all of your goals are and your thoughts about the future of streams and dark matter and the field. But I wanted to start just by sort of laying out what we as the organizers thought about for the goals of the conference and for what we want to try to achieve this week. And so I think we're all probably here because we agree that stellar streams are uniquely powerful tools and they're very interesting ways of studying the galactic mass and the dark matter distribution, et cetera. And even though this is a fairly young venture in the sort of context of astronomy, like binary stars and equilibrium dynamics, things that go back hundreds of years, I think it's a really exciting time to be working on streams because we're now, like in the last couple of years, we're now in a state where we have really precise methods to make great inferences from data. And we now have that data. We have Gaia and many other large surveys. And I think the combination of these two right now has led to a lot of really exciting results and measurements. And so from all of the work that we've been doing, all of you and us, I think we've learned a ton about the galaxy and its structure and sort of left like a lot of the community doesn't even know the things that we know. There's been a lot of surprises and open questions and puzzles and things that we're going to have to grapple with now over the next few years. And so I think to put it bluntly, one of the goals that I have for this meeting is I think we should think strongly about the opportunity that we have to make a really strong case for funding the efforts that we have as a community to sort of enable the next generation of methods and simulations and data sets. And I want to think big along these different axes. So I think it's time to start thinking about the next step of stellar streams and how we can actually deliver on really precise constraints, especially on dark matter. And I think an ulterior motive here that I have, at least, and I'm wearing some branding here from GitHub, is to think about all of this in the context of community building and on infrastructures that will enable us to share and support open data and open software. And I think sort of taking as an example the exoplanet community, which has really been an exemplar on this front. They share everything, and I think that's made the community and the results that they have a lot stronger. It hasn't hurt the collaborations or the research. So I think this is the exoplanet community has demonstrated the power of this mode of scientific collaboration. And so the goal of this meeting, though, is not to solve all of astronomy or dark matter or streams or anything like that. This is really, I think, the first in what we hope will be like a recurring series, more frequently than the last time we had a streams meeting, which was 6 years ago or something like that, hopefully yearly, say, and that these meetings will be a way for us to communicate and coordinate efforts and to try to then also branch out and establish closer connections to other fields that are close to what we're working on. So we hope that this meeting is really about setting a precedent for building connections and collaborations, and then future meetings, hopefully in person, will then further this goal. So next slide, Cecilia. Thanks. So on that note, I want to just take a moment to acknowledge that the past year has been incredibly difficult for everyone I know, for me, for my family members, for everyone, all of my scientific colleagues. And so relevant to this meeting, which is really heavily discussion focused, I want everyone to remember as you're engaging with other people that many of the challenges and the feelings that people have been dealing with are extremely individualized on many different axes. And so please try to be kind and constructive and patient with everyone that's attending and with all of the things that you're contributing. And so we've tried to make the meeting as asynchronous as possible and give different ways for people to engage. If you can't make certain discussion sessions, that's totally fine. There's other ways to engage with the talks, the speakers, and the discussion topics. Well, all of that will be happening on Slack as well. And then related to this, many aspects of the meeting that the other SOC members will talk about in a minute in more detail are pretty experimental. So we'll be collecting feedback throughout the week. If you have comments or things along the way, please feel free to email the SOC or message any of us on Slack if you have concerns or anything. And so the last thing I want to bring up, if you go to the next slide, is for the discussion sessions that we're having, it's important for me and for all of us to remember that talking and asking questions remotely over Zoom is very different, or can be very different from how it is in person. And so think about how you're engaging with others, be mindful about how your comments or your questions may come across to others, try to be supportive. And so related to all of this, we've adopted the Flatiron, or I guess it's the Simons Foundation's Code of Conduct. It's similar to other code of conducts you may have read, and you've already agreed to this in the registration form. So just please be mindful of the values that we have, things that I mentioned before, but also think about the code of conduct for a more explicit list of things that are not acceptable during this meeting. So if you witness anything that you think would be against or violate the code of conduct, again, please feel free to email the SOC, any of us individually or to our joint email address here. So that's all I wanted to say as an intro. I don't remember who's talking next, but yeah, me, Jason or Cecilia. Yeah. Okay, take it away.
Yeah, so a quick word on the structure of this meeting. So we designed this meeting so it has two key components. The first is a fully kind of asynchronous component where many of you have contributed fascinating pre-recorded talks, and many people have begun asking questions via Slack. Something Cecilia will talk about in a minute. And then the other component, so this sort of synchronous component, is a daily 3-hour session, which is an opportunity to discuss those talks and discuss sort of broader questions. And so every day we're going to meet at this time, 2 o'clock GMT, 9 a.m. Eastern Standard Time. We've decided to split this 3-hour session into 2 1.25-hour discussion sessions with a half-hour break in the middle. So after we've finished this introduction, we're going to hand over to some moderators that that have been selected. So today it's Ting Li and Guillaume Thomas, who are going to introduce today's topic and give a brief overview of the talks that have been pre-recorded. And then they'll pose some general discussion topics. And then to kickstart the discussion and to get people used to this kind of format, we're going to split into random breakout rooms so people have the opportunity to say what they're thinking, what they thought about the talks, and that before we come back together after about 20 minutes and continue discussions as a larger group. At that point, we're going to look for people to take notes. Again, Cecilia will talk about this a bit more in a moment. And then after 1.25 hours, so at 3:15 GMT, we're going to then have a break of half an hour, and we're going to move across to WanderMe, which is a better platform for having more informal discussions. So yeah, this is an opportunity to just chat with people if you want, continue discussions, or just have a break. And then we'll reconvene 3:45, continue discussions on hopefully 2 topics that have been selected from whatever comes out of this first session. And people can then opt for one of 2 breakout rooms to join, depending on which discussion they'd rather participate in. And then we'll come back together half an hour before the end for some wrap up and some general concluding remarks. And then everything will be done by 5 o'clock GMT. And so, yeah, we're expecting, we initially, we were really surprised by the number of people who wanted to participate in this meeting, and it's really great. Now we've got 114 people on the call. I think over 200 people registered, and we had a large number of talks as well. I think over 60 pre-recorded talks. And so with this big group, we obviously need to think about how exactly to structure the discussions that we're going to have. So it's important to observe the normal Zoom etiquette that everyone is used to by now. And please can everyone make sure your name's clearly in the participants list on Zoom, and if you'd like to, list your preferred pronouns. During the big group discussions, we expect people to use the raise hand feature so we can sort of have an orderly discussion. You're also welcome to use the chat, and we'll try and monitor that. And then, yeah, when you speak, if you can use your camera, that's great. And yes, everyone who registered agreed that they were happy for the Zoom sessions to be recorded. But yeah, if you're not happy with this, then you can just turn off your microphone, turn off your camera, and only engage via the chat. So thanks, that's all I had to say. So I'm going to hand over to Cecilia.
Hi everyone, I'm Cecilia Mateo, and I'm going to give you a quick overview over the platforms we're going to be using during the meeting for the discussions and the coffee breaks. And we're going to try and make it as little daunting as possible. We try to minimize the number of platforms that we're going to use, but you'll see that the ones we decided on have each their own advantages. So if you're not familiar with it, please book the meeting homepage, bookmark it, and remember that the password is this one. You'll probably only have to use it once. So if you haven't logged in, this is the landing page. You'll introduce the password here, and you'll come to this web page. So this is where we centralize all the information. We're going to try and avoid bouncing back with emails and stuff like that. So here on the top, you see this bar where all the relevant links are listed. So I'll go very quickly over this part. So you'll see the banner of the conference. If you scroll down a little bit, you'll see the meeting schedule. So here's the schedule for today. Today we're going to be talking about the Milky Way streams and substructure topic. These are all the pre-recorded topics links, so you can access each of the recordings by just clicking here. And even if you hover, you'll see the talk title. So you can access the pre-recorded talks this way, or you can also click here on this top link, recorded talks, and that will take you to the Dropbox folder where you will find a folder per day. So inside each of these, you'll find all of the pre-recorded talks for each of the 5 days of the week. So that way you can access all of the talks, and we hope that you already have started looking at them. We also have a summary of all the talk titles and abstracts that's listed here in this Google Doc. You can access through this link. You'll see there the person's name, the talk title, and the abstract, and also a short note in the duration. Remember that we had mainly 2 types of talk, the long ones, which are 10 minutes, and the lightning talks, which are about a minute. So please have a look at that if you want to see the abstracts and the titles. So now for the interactive part. Adrian and Jason have already mentioned Slack. We really encourage you to use Slack for the discussions as opposed to the Zoom chat. We'll try to minimize use of that during the discussion sessions, because the problem is that the chat on Zoom disappears, whereas the ones we have on Slack will stay there. So those are better for asynchronous discussion. So if you haven't done so, click there. It will log you on to our Slack workspace. And, oh, sorry about that. That was a bit of a, okay, I think a slide disappeared there. So if you go on to here, this is the one I was looking for, sorry. Okay, so if you log on to the Slack workspace, in case you haven't used Slack before, we have set up different channels, 1 per day, and inside each day's channel, we have set up threads for each one of the day's talks. So all the discussions regarding a specific talk, you can have in that thread. So that's already going on. There's lots of people already who have asked questions. So please use this feature and you'll see how very practical it is. And it's very time zone friendly too. So the next bit are the intro slides. Because we have 3 hours, which is not a lot of time for 200 participants, we'll try to avoid people having to introduce themselves once the discussion sessions begin. I mean, other than perhaps saying your name. So if you want to see what people's research interests are, then please go to the intro slides, and there you see this type of information. So for per participant, there's a slide with a full name, affiliation, photo, and a few details. So have a look at that. We already have over 80 slides filled. And if you haven't filled yours, then please go ahead and give us some information about yourself. There's a couple more things. We also have a Google Doc with the running notes. So we encourage you to write down the salient points of the discussions of the discussion sessions. So you all will have editing, already have editing permissions. So the running notes document is divided by day. So you just click on the day, and then you can write down here things that you find interesting and want to remember about each of the discussion sessions. These documents will all be public after the conference ends. Also, we're going to use this to vote up the different breakout topics that might come up during the discussion sessions. So keep an eye on this. And once we start listing topics here, just add your vote with a plus. And there you go. We'll use this to decide on the topics that we'll select for the second half of the discussion sessions each day. And finally, for the informal discussions, we'll be using a platform called Wonder. If you haven't used this, you'll see this is very fun. Once you have more than, I don't know, say 5 or even 10 people on a Zoom call, it gets basically impossible to have discussions, without a lot of protocol. So we want to encourage informal discussions, and this is very useful. This platform, Wonder, is very friendly for that. So we'll move from Zoom to Wonder during the coffee breaks, and you'll see there that you'll have an avatar with your picture that gets taken, your selfie that gets taken the first time you log in. The password is the same as for the meetings homepage. So you'll log in there and you'll be able to approach whoever you want and just have a chat with that person. And then if someone else approaches, then a circle gets formed and you'll be able to have, I think, the best online, the closest online experience to having a chat with a group that wasn't preordained or something like that. So we hope you enjoy this feature during the coffee breaks. One warning, this does not work in Safari. So if you click on the Wonder link and it takes you, if you're doing this from Safari, it's going to tell you to use Chrome or Firefox. So bear that in mind. So I think that's it from the platforms. And now I'm going to hand over to Anna Bonazza.
Hi everyone. So nice to see you. Looking really forward to meeting you all throughout the week. As part of our legacy, yeah, all of this sort of choreographed meeting design was really done with this purpose of kind of taking stock of where we are in the field, identifying what are the big questions, the big challenges, and how do we go forward and turn them into opportunities. And we hope we'll be learning a lot. And we, as Celia mentioned already, we'll be making a public record of the discussions that end up in the Google Doc. So thank you in advance for discussing stuff on Slack and also supporting some of those salient features into the Google Doc. We also were hoping to produce a more kind of concrete document with our conclusions and recommendations at the end of the workshop. And on Friday, we plan to discuss these community efforts and resources and discuss the scope of this document. And the reason why it's sort of undecided at the moment is that we are like, I guess the scope of the meeting changed. When we were first planning, we were thinking that we'll have 50 participants working in the field, and then we'll sort of kind of find out, get our recommendations and present them to the broader community. However, the top kind of reason for attending the meeting was from people saying that, oh, I'm not actually working on streams, but I'm really curious to see where the field is at. And first of all, thank you for being here. We are so fortunate that we will get to sort of craft our message to the community while having all of these diverse perspectives from the community at the meeting. So with that, please, if you have any ideas, email us, comment it on Slack, on the Google Doc, and let's have a great meeting and let it be the first of many in the future. Thanks.
Awesome. Thanks, everyone. So I think at this point, we're going to turn it over to Ting and Guillaume.
So thanks, XOC, and thanks organizer for this great meeting. So in the next few minutes, me and Guillaume is going to kick off the first day session on Milky Way streams and the substructure. So I am Ting Li. I'm a postdoc at Carnegie Observatory. So welcome everyone, and so we would like to discuss the Milky Way stream and the substructures on first day, and hopefully this will be landing for all the necessary resource in terms of data and interesting streams for the science will be talked about on the next few days. So in the first, maybe first half of the introduction part, I will briefly highlighting the talks we have received on day one and highlighting the talks, and then Guillaume is gonna bring up some discussion topics and questions for us for the rest of the session. So we got about 17 talks in day one session, and a lot of the talks are focused on either one particular stream or a set of streams. So I decided to first do some grouping or say classifying on the streams. So first I did is to separate them based on the progenitor of the stream. So you can see some of those are from disrupted dwarf galaxies, and some are from the globular clusters. So the ones from the dwarf galaxy on the left, including like Antler 2 dwarf galaxy, and Sagittarius stream, Orphan stream, Indus stream, and Nix stream. Those are the ones in day one's talk. And on the right-hand side, there are a lot of globular cluster streams like Guillaume, GD1, and NGC 5466 tails, Jet stream, Phoenix stream, and M92 tails, and Firmberthal. Oh, I would like to say that you will hear a lot of people's name and a lot of stream name, and a lot of which I'm not familiar with. So apologize if I pronounce it incorrectly. I'll try my best doing that. So these are the subject of the stream that in day one's talk. But I want to also highlight another one kind of in between of the two is on the 12 new globular clusters discovered in the Sagittarius dwarf, presented by Dante Minetti. So it is not on particular stellar streams, but I think it's extremely interesting, not only because it's associated with the substructures we will discuss on day 3 for like the small scale perturbation, but also it kind of, I put it here because we not only should think about like dwarf galaxy streams and globular cluster streams are related because they are all streams, but also that a lot of these globular clusters, which are the progenitor of those stellar streams, are probably in the past a globular cluster of those dwarf galaxies. And we see these globular clusters in Sagittarius, and some of these must be also the globular clusters in one of these dwarf galaxies. So we should always keep that in mind. So just keep in mind for the rest of the talk, the red always means a stream originate from a dwarf galaxy, although some is question mark that I will mention that later. or from the globular cluster is always in orange. So the other way to characterize them is through whether or not we still see a progenitor presenting in the stream. So there are progenitor ones and progenitorless ones, meaning that the progenitor are likely fully disrupted, and therefore we cannot associate the stream with a particular progenitor. However, I want to highlight like the Yule stream, actually Yule stream and a Fimbulthal stream, which were originally found as the progenitorless stream, that we don't see a progenitor with them, but later on from the kinematic data and also chemical data, that people starting connecting these streams with a globular cluster or a dwarf galaxy. So I think this is kind of very exciting, but also telling us that some of these progenitorless streams or possibly still have a progenitor, we just haven't found the association yet. Okay, so these are the way how I separate them based on the stream itself. But now we're gonna look at these from a different perspective in terms of the data. So first, I wanna highlight a few talks that either it's discovery or rediscovery and characterizing the streams using photometry and astrometry data. So first pair of talks that I would like to highlight is from Matt Berkeley and David Shi on this very fantastic machine learning algorithm called VM Markini. So not only that they recovered the 10 node stellar streams, but more excitingly that they are currently working on investigating 580 new candidates from this first searching. So I think this is definitely one of the future ways to discover more streams and doing it more homogeneously. And I want to tell you that there's a lot of discussions about this in the Slack channel already, and I highly encourage you to take a look and join the discussions. And so if I say those two talks are using the Gaia data, but with more advanced or neat kind of algorithm, then the other discovery or rediscovery of the streams, they rely on a lot of great data. For example, using the Canadian France imaging survey data, Guillaume Thomas and Jacqueline Jensen have been able to find the tidal tails of the globular cluster, especially for the M92. It's the first detection of the tidal tails around this globular cluster. And thanks to the U-band photometry from the CFIS survey that provides the metallicity from photometry, so that it can improve and largely decrease the contamination from the Milky Way foreground. And also the other one I would like to mention is from Peter Ferguson's talk on jet streams using the DCAM local volume DELF survey. So a jet stream was previously discovered from the SLAM survey, but the work led by Peter showed that the stream at least is at the length of over, I think 27 degrees instead of the original 11-degree length, though that's kind of largely extend the known length of jet stream. So if this is under a photometry, astrometry part, then a lot of work in day one's talk is related to spectroscopy after the photometric discovery, either using low resolution or using high resolution to study the kinematics, the metallicity, and the stellar abundance. So here are some examples. For example, it's not on a particular stream, so I didn't show it earlier, which one is in blue, but Andrea Koch Hansen using the SDSS data showing that 10% of the halo stars are coming from the accreted globular clusters. So that's very interesting result. And also Geraint Ruiz using the S5 data showing that the Phoenix stream is at metallicity about -2.7, which is more metal poor than any of the no globular clusters. So that's kind of open a new regime to tell us about the globular cluster metallicity distribution. And Alex G used the S5 data showing that N-Taylor 2 is under tidal stripping using the kinematic data, but using the metallicity of N-Taylor 2, it shows that the N-Taylor 2 has not lost a large fraction of stellar mass. And Eduardo Bautnot using the WHT data to show that there are multiple stellar populations in GD1 using the CNCH intensity variation. So if these are done using that low resolution spectroscopy, then there are also a lot of things we learned through the high resolution spectroscopy. For example, from Daniel Zucker's talk using scalar survey, he argued or discussed whether or not NIX is actually a stream originate from dwarf galaxy or it's actually coming from the 6-disk star, because he found the chemical bonding pattern is very similar to the 6-disk. And finally, Alex Riley tried to link the globular cluster NGC 3201 with the yaw stream through not only just chemistry, not only kinematics, but also chemical abundance of the stars. So these are also very different perspective. And also in this day one session, we heard a lot of great data set if it's not on a particular stream. And those data set are either associated with a particular type of tracer or with a mix of those. So for example, Camila Navarrete's talk present a very beautiful data set with over 200 R-Lyraes that all have the 7D, including the radial velocity measurement on the R-Lyraes in over 11 overdensities. So we'll have hopefully we can use this great data set to study those overdensities. And similarly, connect to R-Lyrae, Zanik Prudo's talk showed the orphan streams using R-Lyrae and RGB stars in 7D. And if R-Lyrae is a common or well-known tracer for studying the Milky Way substructure, I would like to highlight that Hitesh Lara's talk, it was a brand new, so at least a brand new tracer for me to study the Milky Way substructure, especially in streams, are using the type 2 and anomalous sapphires to do that. So I encourage you to take a look at this. And also it has the radial velocity measurements, so it's providing the 6D information. And the other different tracers that are used in streams are like a BHB star and RGB stars. So, so blue horizontal branch and the right gen branch stars. So Jacqueline Jensen's work on NGC 5466 is using those tracers. And I also want to highlight this great data set from Paul Roma's Sagittarius stream that a total of over 200,000 stars are found in the stream, in the tail of Sagittarius. And if you look at the top, you will see this four-tail structure, which is threatening. It's interesting, but also a little bit threatening. So I definitely would like to learn more about this. The other thing is from the S5 survey with all the other data that Geraint Ruiz and Alex Xi was able to show the 7D information of the Phoenix stream and Antilayer 2 using the RGB star. So if all of or 99% of the talks that if they use proper motion nowadays on streams is using Gaia, then I want to highlight the last one here, which is something we should consider for future surveys. So Tianqiu first time showing the proper motion measurement at over 100 kiloparsec using HyperSpringCam plus SDSS. So this is the great data set that tell us what we can do basically in the era of LSST. And for the first time, they can measure the tangential velocity dispersion on Sagittarius stream. So the last piece of this building up this 6D or 7D is on the distance. It's very hard to measure, but I also want to highlight that using R-Lyrae stars, BHB stars, and the sapphires, we can get those information on the distance. Okay, so this is kind of the way we look at the day one talks through different angles, but I finally want to highlight that another classification, or say the way I group them using the talk format or talk style, that is Paul Roma's talk versus everyone else. So if why you think I do this way, I think you should take a look at it. It's really creative and it gives us a brand new way to think about how we can make talks, especially these pre-recorded talks for this online conference. So yes, take a look and you will know why I put it here. So yeah, I used about the past 10 minutes to highlighting all the talks we have had in day one. And so give us an idea what has been covered. And based on these, I'll turn it to Guillaume to kind of bring up the questions and topics we can discuss in the following session.
Yeah, so thank you, Ting. So yeah, I'm Guillaume Thomas. I'm a postdoc at the IAC in Spain, where, believe it or not, it's pretty cold here. So yeah, so after this really nice introduction, we can already have some conclusion or some question about the different talk that we've seen in that session. And the first one is really, the big question is to know, in the recent year, we discovered a lot of different stellar streams, thanks to different cores, thanks to Gaia also, a lot. And so the question now that we have is, do we still need to push to discover more streams? And so in that cases, do we care about the completeness? And if so, why, for example? Or do we need to get focused on the characterization of the already known streams? Like, what is the progenitors of the different streams? Do we need radial velocities and things like that? So yeah. The second question that we can have is also what needs to be done from the discoveries to being a streams for the studies. Especially this is more to bring a discussion between observers and simulator, what needs a simulator from observers and observers from simulator, even if I'm not a big fan of the classification. But yeah, so it will be to bring also what do you need from the data, or what do you need from the simulation to be able to go ahead and to continue to do this really nice work. So again, it's just ideas of question, and it's just to bring some ideas of discussion that can be made for the sessions. The next one, please, Ting. Yeah. Yeah, so other question that we have is also what are the most interesting objects to focus on for the studies? Are the 4 classical streams, well, which is Sagittarius, PAL5, GD1, often, that was the 4 earliest discoveries of them. Do we have to continue to push for them? Do we have some things that we can still learn from them? Are there still more interesting new streams that we discover? Another thing also is what type of stream is the most interesting for you or for the different part of your research, with or without progenitors, from dwarf galaxy, from globular cluster. For myself, for example, doing simulation, I really like when there is a progenitors because it gives you a few indices about how to start your simulations, which is pretty useful. So again, it's a lot of discussion like that that I guess we can have today. Next one, please. Yeah, also when we were looking for the stars, for the talk, we saw that there was a lot of them speaking about spectroscopy, and that we either are starting spectroscopic follow-up or are planning to do that. And so the question that we have with Ting was, especially, what is the most important? Like, if you have a token to spend, would you like to get not a lot of spectra, but like really high resolution, or do you want to get a mixture like low resolution but quite significantly, or do you want all of them? And so in that case, we need to build a dedicated spectroscopic telescope. So yeah, so if you have a token, I would be really interested to learn what will be your choice. Also, as I was mentioning Ting before, we are seeing in the talk that different tracers have been used to do these different studies. And the question that we have right now is what kind of tracer for you as the most interesting, or especially to do the spectroscopic follow-up? Do you think we need to target about getting all BHBs, spectra for all the BHBs in the sky, all RLI rays, or just random RGBs is good enough? Also, where in the stream would you like to get spectroscopic surveys, if possible, because we know that it's very expensive, it's pretty limited. So do we have to focus somewhere, or do you want just random patch at different position? One of the questions that I had also was from different talk. We see that there is a different argument about where is ending, where is finishing a streams. And my question was, do you think it could be interesting also to focus on the area where the stream are finishing or endings, just to be sure it is exactly where there is, and there is not a part of the other streams that is there, especially also to find if there is a feigning part of the stream or anything like that due to perturbers like the bars, spiral harms, and so on. And finally, also because we do spectroscopy, it will be the question of what lines do you want to focus on. It's depending also on the resolutions. But again, what kind of feature do you want? Like, do you want molecular line? Do you want different metallicities line, different elements line? So I think it's really interesting questions that we have to think also ahead for the next generation of surveys. Next one, please. And finally, other question that we had was about the origin of different streams, and especially the one from recently discovered really metal poor globular cluster. As I was showing Geraint Lewis with the Fenning streams, for example, it seems that the progenitors has a metallicity lower than the metallicity floor of globular cluster, with a metallicity lower than any node globular cluster around the Milky Way. And so arise a question about the origin of that streams, as they are from accreted in situ population, as there's a cores of the remnant of dwarf galaxies, as they're coming from different parts. Where are they coming from, basically? And I think that we can ask this question not only for them, but for all of them, like for the dwarf galaxies one, for the globular clusters one. Can we find group of streams linked together? Can we see if there is a group of globular clusters, for example, that arrive together now in different stage of disruptions, which again can tell us maybe something about the Milky Way SMB history. And so that's also the other question is, what can we learn from streams? Well, we know that we're going to speak a lot about probing the dark matter composition in the Milky Way to probe the galactic potential. But also, what can we learn from the Milky Way archaeology, from the Milky Way history from them? So all of this as questions that I think is interesting and have been raised either in the chat, also in Slack, or also that I think the community have in general. So yeah, so I think that now it is a time to split in different sessions. So maybe the organizer want to speak about that.
Yeah. Okay. So I think let's give just a couple of minutes. First of all, thank you, Tengen. That was awesome. That was perfect. Exactly what we were hoping for. So I think we should maybe just take a few minutes to see if anyone has anything they want to raise right now with the full group to add to the sort of list of brainstorming topics that we're then going to break out and discuss. Does anyone have any pressing things they want to add to the roster? You can also feel free to add this to the running notes if you have any comments or things that come up. And if you do want to say something, please just raise your hand on Zoom.
I also would like to add, in case people want to look at the slides, those are also linked to the Indigo, in case during your breakout discussion, you want to go back to the question list we put here. You can find them in the Indigo page.
Great, thanks, Ting. Heidi asked a great question in the chat. How do we tell which streams are real and which ones are associated with one another? I don't have an answer, but yes, let's add that to the list of topics. Good. Okay. Well, if no one has things to raise here, I think we're going to split out into 10 different breakout rooms. The moderators and the SOC will be sort of floating between them. So we're going to try to distribute amongst the different breakout rooms so that we can help moderate or help take notes and things. Carl raises the point, spectroscopy of stars in and around gaps. Yes, that's another great thing to discuss, or a sub point to put under the where to focus our observations, I think. So I'm going to attempt to send everybody out to breakout rooms. The breakout rooms will not be recorded. You can, if you want, moderators, you can enable recording, but I'm okay with not recording them as long as we all agree that we try to keep notes of the key points that come up in the different breakout rooms. When we come back into the bigger session, we're going to try to have people then bring some of the key points that you discussed in your breakouts back to the full group. So do think about when you're in your breakout room, who might be willing to share some thoughts. We're not going to go around breakout room by breakout room, but just think about who would be willing to bring something back to the full group. So keep a record of the types of things that you're talking about. All right, let's see how this goes. Oh, welcome back, everyone.
So yeah, so I hope that the different discussion was really useful and fruitful as it was in my room. So do we have people that took notes that want to report that happened in the different rooms?
And I also want to add, we encourage people to put notes also in the running notes part. If you feel you get anything useful, please put there.
Yeah.
And just to explicitly say for everybody, the goal now is to try to collate some of the themes and the topics that or questions that came up in multiple rooms that seem to be of common interest. We're going to put those into the list in the running notes, and then over the next half hour or during our break, we're going to vote on the different topics. And then the next session after our break, we'll take the top 2 of those things that have been upvoted, and those will be the names of the breakout rooms, and you can choose which discussion you want to go into after this. So the goal right now is to sort of collate all of the interesting things that we talked about and try to find the common threads.
Yeah, I think I'll put like some people on the spot. We in breakout room 3 were talking about whether we need more streams or what kind of data we want on streams. So I don't know. One of the Alexes. Go ahead.
So I can read the notes that we took and elaborate on them, but I'm a highly biased on this perspective, right? But I feel like we're sort of in the domain where each new stream we discover ends up telling us something new. What that new component is varies a lot from stream to stream, whether it's something about the global Milky Way potential, something about the baryonic structures, the bar, the disk, baryonic perturbers in the halo. And so to this, at this stage, we still do benefit very much from having more streams that allow us to better cover this very multidimensional phase space. And especially as our observations get better, we're going to be probing different parts of the halo, in particular farther out, where we may be able to break degeneracies between dark matter substructures and baryonic substructures, for example. Alex brought up a good counterpoint, so I'll throw it over to Alex G if he wants to have these said.
Sure, I can add the counterpoint quickly. I guess the point that I brought up was that we all define what an interesting parameter space is differently, and I agree with Alex that there's lots of new streams, but in a particular region of parameter space, I think we have not characterized in any given region of parameter space. I think we have not characterized individual streams that well, and for a lot of questions like small scale dark matter, I think that really helps a lot.
Nice. So discussion in other sessions.
I could talk a little bit about room 2. Room 2, we had the same question we converged on, which is where do we need the next data? And I think that our running notes are not very complete because it was too interesting. I want you to guess who was in the room from what we actually came up with, which was that in terms of history of the galaxy and reconstructing accretion history, then we need to find more and more streams. But for the case of potential and potential measuring, then what we really need is some more serious theoretical work, which is completely behind the times in actually being able to meet the quality of the data in terms of interpretation. The reason we want that theoretical work is because the Milky Way is special in the sense that that's the one place we can get detailed constraints, and we can't do this yet because we don't have the modeling techniques. And then in terms of looking ahead to data, we did try and address this. Another bias, we agree with the past group that outer halo is the discovery space, but it's also the place for potential constraints. So if we want to, for potential constraining, that's the region we might want to look at. And then we had a discussion about how there were objects in the inner galaxy that looked like they explore the outer galaxy. So maybe the challenge is to find the stars in the outer galaxy which are connected with those inner galaxy objects. And we ended on a discussion of what do distant shells look like from the inside in the outer galaxy, and how we can actually connect things into shells. And Pao, do you want to have a comment here? He's smiling.
Yeah, I mean, I think it would be pretty interesting, but as I said, these things are pretty far away, and I think the challenge is how to connect them with the scarce data. I mean, are you going to get good distances, good enough to make them clamp in distant space, or are you going to have radial velocities to complement the proper motions from Gaia, which is limited in magnitude, to get decent orbits and then put everything together and connect these detections at different places in the sky into a single shell coherent in space? Yeah, I don't know. I think it's quite challenging.
Yeah. So was the sessions? Was the idea something similar?
I can say something about, I think we were
again.
session 4. So I think one common thing we identified with most of these questions, I think it's also mentioned in the chat, we don't really want to choose. We both want lots of streams and we want good data on them because they of course telling us different things. So I think it's good to focus, have different people focusing on different things. I think that's something we all agreed on. Towards the end, we had an interesting discussion started, which kind of was cut short a little bit on the detectability of streams and kind of how we can estimate completeness limits, because if we want to look at the accretion history, we kind of have to be able to measure that, and it's a bit more complex, I have the feeling, for streams than for, say, dwarf galaxies, because especially when the discovery is more than just the surface brightness, also incorporates, say, proper motion clumping. I think we will need to look at that for future comparisons, say, to simulations or expectations, right? So yeah, that's more or less, I think, what we talked about. If anybody else from the group wants to add to that.
So I see in the chat that Jean has something to say.
Yeah, I can report briefly about the breakout group 10. And one question that we raised was the importance of getting not just more streams, but rather get more precise data about the existing streams, in particular the line of sight velocities with the sub-kilometer per second precision around the gaps, which will tell us the physical nature of these features.
Yeah, so, well, quickly also in my session, we were speaking about the gaps, and that we need a really high resolution velocities, like sub-kilometer per second velocities around the gap, mostly focusing. Yeah. So any other sessions to report?
I tried my hardest to not be the person reporting from my breakout room, but it's me. And we went in sort of a different direction. We started talking about the LMC and large scale perturbations, but then we came back to the question of how do we study these things, and how do we do, as Catherine was alluding to, like, how do we improve the realism of the simulations that we're using to compare to the data that we have. And I just wanted to raise this as a point that many of us are probably aware of, but one of the challenges here is that as far as I know, none of the like default simulation tools that our community uses are really well suited for the problems that we're after. Like, you can't just turn on Gadget and simulate a dwarf galaxy in a Milky Way and a globular cluster forming a stream. And it's very hard to then also turn on N-body 6 and do the same thing. So we need to be able to resolve really large dynamic ranges, and we can think of it. Rafael Arani had some good ideas about how we can build custom tools to do that, but they don't exist right now. So I think that's an important part of connecting to all of the substructures that we see is being able to simulate more realistic systems.
Yeah, that's a really good point as well to raise. Yeah, so in my room, we get also a bit of simulators as well, and we get a chat also about difficult it is to reproduce a progenitor less streams, because when you have the progenitor, it's easy to start your simulation. You just need to get back and you can do N-body simulation. When you don't have this, it's really hard to get, because in a lot of streams we don't have radial velocities, or just in really sparse different positions. It's really hard even to extrapolate also the velocity profile. And also for the precision of the different observables, as we was mentioning Jean before. One of the things also that was raising is the need of really precise distances beyond just error libraries and BHBs, because it is really sparse population. So to try to detect stream just with that, it can be kind of challenging, or maybe we can pass through, we can miss a lot of them, of the detection, especially in the outer halo. So we really need to get better distances. And that question is, how can we do that? And it's still unclear on that aspect. Yeah. So I see Rohan also raise hand.
Yeah, I'm going to report on behalf of room number 1 and try to summarize some of the issues we discussed that haven't been brought up yet. So one very fundamental question we asked, which might resonate with a lot of folks on this call who are not streams people, is what is a stream? In that there's a lot of photometric surface brightness over densities that have been reported. There's some short stubby ones. There's tons of them from it was brought up from pan-stars and now from Streamfinder. So is that what we think a stream is? Or do we say that we need some kind of second order radial velocity follow-up or some kind of indication of chemical coherence before we designate something as a stream? And this might also feed into some of the community efforts that Adrian was talking about, where maybe we get together to try and figure out various bands of significance or how much data we have on a particular structure. So that is one set of issues, which I think is pretty foundational to what we're discussing here. Another set of issues we discussed was around how much data do we actually need and want on a stream? We've heard a few opinions on that already. So some opinions we had were that maybe for you want to absolutely do high resolution chemical follow-up for a number of stars ranging from 3 to maybe hundreds, because velocity dispersion needs 3 stars. But then we also discussed that maybe this is something that you really need to think about on a case-by-case basis, because for some streams, just based on Gaia data alone, you're able to wind back the orbits and really connect them with very high fidelity to either some very well-known globular cluster or to orbits that are very similar to some some dwarf galaxy debris that we are discovering in greater and greater quantities with other halo surveys. So yeah, I'll leave it at that.
Okay. Yeah. I'm trying to see who else has their hand raising. No one for the moment. So is there any other session to report or any other things to add? It seems that in the chat there is a few of talks about that. Is a stream for dwarf galaxy or star cluster? Yeah, that's a good question. Yeah, well, also, I don't know, for us, we were also mentioning the fact, yeah, I'm just going back every time in my break session room, but we get a lot of different discussion, actually, almost everything that has been covered there. One of the things also that we were mentioning, and maybe we have to be careful, is that a few methods are using are assuming a potential to find the streams, and it can be also dangerous to use that streams where we have been using the potential to detect the potential, then therefore, or to assume the potential behind, even if it is detected with different potential, things like that. At the end, maybe we have a bias of selection as well that makes that you're going to find what you were looking for, actually. So maybe it is something also to keep in mind for when we do the simulation and where we're going to do the simulation of the new discover streams. Yeah. So yeah.
I can also say a few words about our room. I was hoping others would bring these up, but I haven't heard them yet. So on room 8, we discussed also about what is stream, and I just want to add that. So some examples are there are recent reported stellar stream at 100 parsec with a young population of 100 million years. So these are open cluster disrupted streams. So these are also a stellar stream, but are different from what we know in the past. So another way to ask, instead of asking what is stream, it's more for the science, particular science we are interested in, what kind of stream are relevant and interesting. And we should understand the connections better, so that for particular science, we kind of working on particular type of stream instead of asking what is stream, because it's always very ambiguous and questionable. And related to this is another thing we feel like is largely missing in the intro slides or in the conference, but should be relevant, is not on stellar stream, but on those non-stream like overdensity substructures like shells or clouds. So we've been hearing a lot in the past, like Virgo overdensity, triand, but it's not much in this talk, but those are also important to understand. If we want to understand the streams, we should also understand those overdensities and their connections probably to like Gaia, Encelada, Sausage, etc. So that's the other thing that brought up in our room. There are the other points that I hope others will bring them up.
Mm-hmm. Yeah, very good point. So Nora, do you have something to add?
Yeah, I can just give a quick overview of what we talked about, and I think it was room 7. So I think we were all also in agreement that we want to continue discovering more streams and sort of build up our understanding of the completeness of the population of streams we have discovered, because we really jumped into discussing some details of, for example, our methods of discovering streams biased against dwarf galaxy streams versus library cluster streams, things like that. And then we also spent some time discussing how we can build upon current methods of automated stream discovery to discover more streams and I guess build up our understanding of completeness of our population of streams.
Okay, that's good. Is there any other people that want to discuss or to report? Okay, so yeah, I don't know how you were thinking to organize this discussion though.
Yeah, I was just going to say that so far I've been very stream of consciously dumping things into the running notes. So the topics right now are a mess. So give us a couple minutes. We'll try to put them into better shape. And then towards the end of the the break, which we're about to go into, towards the end of the break, add a plus to any of the topics that sound interesting to you that you'd like to discuss. And hopefully we won't just have the same number of votes for all of the topics, but we'll cross that bridge if we get to it.
Right, I think I'm looking at the running notes. Well, we put them all in the topic section, but really they should be running notes. And I see like from people talking about, it's not really, we shouldn't discuss something in terms of like say, oh, should we do A or B? Because it's pretty much the answer is we should do both, right? But instead of the question, I think it would be good for the second half of the session is on like what kind of data we wanted to collect. Or maybe people will answer we should get all, I don't know. But what kind of data we are eager to need. And I see another thing very interesting, I think we should continue is what kind of theoretical effort we need to continue working on. But I don't want to break the two groups into theorists talking to theorists and observer only talk to observer. So we definitely should have the one topic to be something like what kind of theoretical data and like observation data we need, so we can put the people together in one room and talk to each other. That's what I think we should aim to do.
Good. So we will work on that with the moderators. So check back in. We'll send a message on Slack when we're ready for people to start looking at those things. In the meantime, is this Cecilia sharing screen?
At least it's Cecilia trying.
No, she is. She's succeeding. Good. She's showing off the Wonder Me room. You want to take it away?
Okay, sure. So I think I've just posted. I may not have hit send in the chat the link to the Wonder Me. So if you don't see it there, you can also see it here in the webpage, and you'll land in something that looks like this. Of course, I'm already logged in. You'll first get something asking you to get your picture, write your name, and we're going to ask you something like, what do you hope to learn from this meeting? And that'll be shown when you hover your mouse over your avatar, so you can see that. What do you want to learn this week? Everything. Good thing. So you can see the little faces here of those of us who are already in the Wonder Me room, which also answers your question of whether you can have that working at the same time with Zoom, and it apparently hasn't crashed all morning. I don't even want to say that out loud. Okay.
So we're going into a 30-minute break. The idea is you can go into, you move a little avatar around. You can go into any of the areas that you want. You could just tag up with people that you haven't talked to in a while and see how they're doing. This is informal break. Towards the end of it, we'll send a message to the Slack channel and ask for everyone to vote on the topics. And then when we come back to Zoom, those are the topics that are going to be the themes of the 2 breakout rooms. So you are released now to have a break and go to Wonder Me.
And we are starting at in 27 minutes.
Right.
Okay. Just in case you need to step away from your computer or
right.
Anyway, so that's planned to be back at, I guess, 11 Eastern.
Thank you, everyone.
I think Jason's. No.
This is the part where we would all be standing in the front of an auditorium looking confused, but instead we're all looking at our screens like.
Yes, a bell is missing that signals the beginning of the session.
Right.
Yeah, we should try to clap the hand and say, seminar!
Yeah, people are leaving, so that looks good.
Good.
This is just for Eugene.
Well done.
You're doing the next broadcast to reconvene people, Anna.
Yeah, I've been running like the virtual seminar for like a semester, and like this was the warning bell. I also have the applause app, so I can recommend you like the applause number 7 is the appropriate amount of enthusiasm, but not like rowdy like.
I'm offended that none of us have gotten applause yet. I'm kidding.
Okay. Let me check. Okay, I feel like I'm a little bit self-conscious now. It seems like most people are back, so maybe I should not do that. But I'll play it at the end.
So I want to know, like in the organizer part, who is to the dynamic session, who's going to go to the assembly history session? Or all of you going to go to the dynamics one?
I can go to the characterization one. Okay,
I'm definitely going to that one. Yes. To the assembly history.
You mean, okay, good.
Yeah.
I think both session is gonna focus on similar questions, but focus on different angle that has different lines.
Well, on that note, I like the way that you split these list of topics on list of talks into several dimensions, so to say, right? So you can group them by different aspects, and they do really split apart differently.
Mm-hmm.
Yeah, that was a really neat idea. I really like that too a lot.
So I made the subtitle for the 2 rooms that we can put in our running notes, one for dynamics, one for assembly history. If you scroll down, it's after the breakout room notes on the previous one.
Good.
Yeah, I think we have most people here now. It's just been taking us a little while to kind of decide on how to call the breakout rooms to structure our discussion, but I think we have it. have something that would work well. So maybe think can like you can describe the options, and then I think people can choose.
Yes, so yeah, we should start. So after some discussion over the break time, so we decided instead of listing dozens of questions that people to vote, we're just gonna narrow the scope of the science topics and break them into two groups, one focusing on dynamics in dark matter, and another focus on assembly history and the progenitor populations. And so we think that we will have different science focus and also different kind of data focus. So people should feel free to choose one or the other. And we're gonna discuss in the breakout room for 30 minutes and then come back, tag up together for the next 25 minutes to finish in the hour. So that's kind of the plan. So right now, if you click the breakout room, you will see there are two choices, and you should feel free to join one or the other, and then we will continue our discussion there. So see you guys in 1 minute.
Just to say, I think and then the overarching question, I think, is like, what do we want to think about the next 5 years or so in terms of what measurements we want to make, but also what data we want to have. And those two obviously inform each other. There's arrows going both ways. So think about that interface as it pertains to whichever breakout room you decide to join. I think we're mostly back. So Ting and Guillaume, do you want to take it back over?
Yeah, I guess maybe the best way is we try to a bit summarize what has been discussed in each room for like 2 or 3 minutes, and then we can continue the discussion and see the common point between the two different science topics. So I can start first maybe. So I was and others people in the assembly group should also chime in if I miss anything. And so I was in the assembly, Milky assembly history and the progenitor population group, and we had a lot of discussion there. And I think I just want to highlight a few, like in terms of like what kind of question we're trying to answer in the next 5 years. I would say the highlighting is like, where are individuals halo stars coming from? And in terms of their progenitors, what are the frequency of the distribution of the progenitor, and what is the major contributor? And that's kind of the thing we want to understand. And in terms of, in addition to that, it's not only about the distribution, but also the chronology of the accretion event. So when did the system unfold and when the disruption happened, and in trying to understand these. So there are a lot of things discussed again, and we are trying to taking all of these on the notes. And these are the kind of the highlighting questions, I would say. And in terms of what kind of data sets or what we need to answer these questions, we also had some discussion on those in terms of like, we probably want to get deeper data to find more stellar streams in the distant halo. And also we wanted to find streams or the disrupted things, not just in terms of cold stream, but also like much harder, but debris, like harder structures. And another interesting kind of discussion in terms of like whether we want a more outer halo stuff or the inner halo ones. So I think outer halo ones are useful for us to understand the potential constraint. But in terms of the smaller mass and early creation, and Catherine brought up that the inner halo is more useful or more valuable for that. So we want to understand the field stars in the inner halo. Yeah, so there's a lot of things discussing on the accretion history and assembly about Milky Way, and that's kind of the highlights I took, and I'm sure I missed some in case people would like to add later.
Yeah, so for the part of the galactic dynamic and the dark matter search, a big amount of the discussion was about how we can compare the different type of dark matter and the different theoretical models from the observation. and especially to compare between the CA, cold dark matter and the SIDM. And for that, we have been starting to speak about what kind of tracer can we use. So we went to the conclusion that basically we need low resolution for all the sky of spectroscopy. So yeah, we don't ask a lot to the community, just give us spectrograph, please. And to do a high resolution follow-up for interesting structures, which means every time that we detect one. And especially for the streams that have gaps in them, and to focus the high resolution spectroscopy around that gap to get a really precise velocity measurement, individual velocity measurement, lower than 1 kilometer per second. And one of the efforts also that we have to do in the community is to get a complete 100% completeness 6 or 7D observation for area arrays and BHBs. Because they are sparse tracer, easy to get, or so not so much numerous. So we really have to focus on that and to be sure that every time that there is a sparse fiber anywhere in the world, we put an area array as a BHB on it. So yeah, so some of the question was against, yeah, so for cold dark matter, SIDM, so different stream are good to studying different things. For example, for SIDM, I have a big change at a large scale structures halo. So for that, you need to get a large number of different streams, especially in the outer halo, to be able to probe the potential in different position in 3 dimensions. This is the same also to detect the impact of the LMC. It has been raised many times that some of the already observed stream seems to be attracted by the LMC, but to detect really all these different features bring by LMC, Gaia Enceladus, so all these kind of things, we need to get more streams for that. Through is still to be a problem to model many streams at the same time. There have been some attempt in the next years. However, for the moment, we don't have so many streams with all the information, and the effort have been made for 4 or 5 streams so far. But we need to push further away. And for that, it has been mentioned that 5 or 6 years ago at Rimberg, it have been mentioned that maybe we need a common framework for a dynamical model to be able to compare to it, and so the community can just focus on that. The problem that we have is that for depending of what question you want to answer, you need to get different tools for that. So maybe we can converge at some point to some tool to use to do these kind of things to different questions, like do we need to get absolutely a high resolution simulation with n-body 6 to get the gap, or just an n-body model of particle spring is good enough? So yeah, so it's kind of things. Yeah, I think it was basically all of that. Yeah, I was just also mentioning that in MON, for example, you really want to focus about cold globular cluster between 20 and 80 kiloparsec, because the break of the strong equivalence principle modifies the morphology of that. And yeah, and so the question is still that we need more streams basically at low signal to noise ratio with good enough data set with distances, velocity, radial velocities, and so on, to be able to do a simultaneous modeling of the streams. Yeah.
Okay, I think we have 15 minutes left, so it will be good to see like what are the common ground for those 2 different angles, and what are the things we haven't discussed, and we should bring it up here. Anyone wanted to start the discussion?
Well, since there is nobody, I would like to go back to this indeed really nice ideas that we were mentioning 5 years ago in Ringberg, to the common tools to use to be able to do these different things in galactic dynamic, like especially to get the big map of the galactic potential. What is the best tool to use, and what is the common tools that we should use? What is the different properties? What is the different things? What is a specific suites of tools, of Python tools that we have to use, like GalPy, Gamma, I don't know. Do we need n-body simulation, really high res, something like that?
Eugene?
I would say that even a single set of tools is not enough, in the sense that if the potential is not static, then we don't care just about the present day potential, but also about the history.
Adrian?
Yes, +1 to that. I was just going to raise the point that I think something that would be good to discuss this week is, what do we actually report? What do we compare? What is the measurement that we're actually after? Like, I think we're beyond the point where a single mass profile or even the shape of the Milky Way alone is the thing that we're after. We're after something more detailed, something that you can't look up in Biddy and Tremaine. And so I think this is something we should be talking about. Like, what are we after? The evolution of a set of time-dependent basis function expansion coefficients, or is it something else? And so I just wanted to throw that out there as a question.
Oh, I noticed that I think we should have also the running notes. I know we both take very good notes in the breakout session, but we should also keep taking the notes for the spiral session. So I want to make sure there is a place for that right now on the running notes session. I don't think there is. So let me just clear. Okay, someone clear out one. Okay, Anna?
I wanted to pivot a little bit. I'm sure that we'll discuss this this topic of modeling frameworks probably tomorrow in more detail. But what stuck with me and what Guillaume was saying, he said something like, whenever there is a spare fiber, like on any telescope, on any instrument in the world, we need to put it on an RR Lyra star. And so I just wanted to kind of bring up, how do we get to do that? Like, first of all, are we aware of all the different calls for spare fibers, and if there are, how can we be ready to to get on the list?
So I guess the question here is, are we talking about putting a spare fiber on any of these larger scale survey or any of those PI observations that people are doing?
I don't know. I took Guillaume's to be any. So I mean, yes. we can start with what's realistic, but anyway, it was a good kind of discussion of how do we get more data.
For these large surveys, they already do that. Well, I mean, RR Lyras and BHBs are already really high priority targets. So it's hard to do better. But for other dedicated survey, yes, might be the case.
Yeah, correct. That's kind of, so for a survey I'm running, I'm doing all the RR Lyras and Milky Way stuff, but I also have spare fibers. I was wondering if I can do something like high redshift quasars, maybe interest to the high redshift community, but because I'm not working in that field. So I guess the best way is for me, when I'm doing my survey, I will try to reach out people. But if we want to have some data, we also need to identify what are these small scale surveys that are not considered Milky Way component, and then try to convince them to add something there. I think, if we know them better and they have spare fiber for 1 or 2 targets, it's very likely they will say yes. But this kind of communication, I guess, is not very frequent at this stage.
Dennis?
I guess I wanted to get back to the question about what kind of dynamical framework do we need in order to kind of discuss potentials or kind of to share with the community. I do think it's going to be some kind of time-dependent basis function expansion, unfortunately, because that's what it looks like we're going to need, for example, for the Milky Way and the LMC. In terms of what the best one will be, I think it'll depend. I think we need to do some, perhaps some work, both with n-body simulations of the Milky Way and the LMC, but also with cosmological simulations with streams injected into them, either that are resolved, through the kind of star formation processes in the simulation, or injected after the fact, and then test how well can we reconstruct those potentials, and what are we really reconstructing about them, and what precision. And there've been some steps towards this. I remember that Anna had a paper a few years ago, I think, with Via Lactea, but I think we need to do that kind of homework to really understand, what we can and can't measure, and what kind of description we even need to measure it. And obviously, if those simulations have things like the Milky Way, like the LMC in the middle help. So Ethan Nadler has some nice simulations with the LMC in them. So, this kind of approach could kind of help us understand what tools we even need to describe the results. Then in terms of what answers we give, what we say, probably it'll have to do with a force field generated or something like that, something which is the same for all bases. Well, it can be the same. So I think we have to kind of understand the limitations of our work, but yeah.
I completely agree on that. And well, the thing also is to know what kind of things are really meaningful. Like during a big amount of time, we were thinking about distribution function to try to characterize the halo on the Milky Way. Does it still have any sense in time dependent where we are under a big massive accretion with the LMC? And do it, for example, the mass of the Milky Way still meaning something in comparison to Andromeda or things like that?
Yeah, I also wanted to add that this is not only important for the dynamical part, but also to understand the creation history of the Milky Way and the chemical evolution of the Milky Way. I think the N-body and the cosmological simulation is very important for us to compare. So currently, I feel like there is a need for the community effort in terms of what to kind of unify the understanding of observations and also the dynamical modeling and the embodied simulation stuff. I saw Monica earlier raise her hand. Do you want to ask a question or bring up a comment, Monica?
Yeah, no, I was just wondering if, just referring to Dennis's point about time-dependent multiple expansions, is there a way to do this without running large numbers of n-body simulations, or are we, so I guess, if you have n-body simulations, you can then construct the multiple expansion, but those tend to be very expensive to get high resolution. So I was just wondering if people had ideas about how to do that.
And I see Joe raise a hand.
Yeah, I had a related point. So I've been advocating for years that we should be measuring accelerations and using those because streams are quite insensitive to other things than the acceleration just at where you see them. I think basis function expansions are a fine thing. They do tend to have very correlated uncertainties once you're going to start modeling a stream with basis function expansions. So we'll end up with some sort of huge PDF that has no very simple form, I think. And then certainly once you're, as Monica's pointing out, once you're adding time dependence, just putting priors on that is going to be very tricky.
Catherine?
Yeah, I think part of the joy of the basis function expansion is because you can get expansions that solve Poisson's equations, which actually means they are dynamically relevant and meaningful by themselves. And so this gives us power for connecting to through back to beautiful linear theory descriptions. But basis function expansions could also be used in the data. So I'm really excited about basis function expansions because of the dynamical connection, which gives us hope that if we can describe a potential in a simulation through with a dynamical description, you can actually use that more efficiently for inferring dynamical evolution. And then the hope would be understanding signatures in one set of data in basis functions. We may be able to understand what the typical signatures are from using the simulation. So I just wanted to sort of jump in and say, Joe, I completely agree about understanding the basis function expansion itself. So this is a really interesting discussion. I think many of us on this call have been talking about this for 5 to 10 years. And I would caution, I'm tremendously interested and excited about this, but I would caution the observers that this is not a trivial step for the theorists to take and to produce useful machinery in a year. I think that makes it exciting because it's meaningful work, but I think it's not trivial. So that's just a sort of cautionary note. But I started by mentioning the dynamical connection because I think it really could be a quite deep tool, and so that it's worth the effort.
Thanks, Zukanya.
Yeah, so we recently have been able to measure accelerations directly using pulsar timing. But one issue with that at the moment is that it's limited to the nearby, relatively near the sun, within about a kiloparsec. So what I'm interested in learning here is if we can come up with a sort of integrated approach where we use streams for the more distant galaxy and direct acceleration measurements more nearby.
Oh, I think Catherine wanted to comment on this.
Yes, sorry. Thanks, Sukanya. You reminded me of something else I wanted to say in response to Joe, and you sort of brought it up, which is I actually think the point about the streams measuring local accelerations, that's really fun, but we do want to connect many streams at once. So in a way, again, I'm excited about basis function expansions as a frame, a flexible frame which you can tie many streams together in one and constrain the expansions at once. Okay.
So can you not have an overkill with that? I mean, like, so just a remark of that. Like, if you give too much freedom to it, are you not just overkill actually what you are looking for? It's the root signal that you are looking for. The second thing that I was actually thinking was about, we just speaking about the outer part of the galaxy, but actually the stream can also give us information in 3 dimensions and also in the inner part of the galaxy where we don't have a lot of other information, like inside the bar or in the bulge or things like that. So is there any other kind of stream also that we can use for that, and what kind of bad or good description will be to use in that case? Is that BFE? Is that just Poisson equation? Or is that?
I want to say these are all great discussions in terms of especially on the dynamic modeling, but we're at the hour, and I think the whole day tomorrow will be focused on the dynamical modeling on large scale that people can have further discussion. We are close to the end for this session, but we'd like to know if there's any other things people would like to bring up in terms of Milky Way streams in general. And I want to also encourage people to look at the nodes if you are in one parallel session, but not in the other one. And there are a lot of points bring up there, but maybe not brought here. So Anna?
Yeah, I just wanted to say thank you everyone in the chat. I think we are starting to get like this, our life roll-up figured out. So this is exciting.
Great. That's good. You just bring up a question here and then there will be answers and solutions just in 10 minutes. Alex Dirk Wagner.
I was just wondering if we have time maybe later in the week to talk about large facilities and how they could benefit this science. I'm not sure that it goes in this session, but maybe in the last day.
Yes, I think on Friday we'll be focused devoting on like the community effort and resources. So that should be definitely bring up there. Okay, any other comment? Or Anna, is that still another comment you want to make? Or? Okay, if not, then I think we are good at the hour, and thanks everyone for coming to the first session. I think it was experimental, but it runs pretty good, and I think we have at least recorded a lot of notes from this session, and I definitely encourage we continue the discussion either via Slack, or I don't know if the Wonder thing will be continue open for the rest of the day, or just that 30 minutes break if people wanted to have more kind of small group discussion. I guess that I'm not sure if that's a place to open for people to go. Yes, okay.
Sorry, I'll just jump right in. The Wonder Room is going to be open 24 hours. So if you want to join in right after we wrap up here, you can. Or if you want to come in early and just have a cup of coffee or a beer or whatever with someone and chat before we started these discussions, you can also do that. So feel free to join in whenever you want.
Yeah, so
our only request is to record some takeaways from any discussions you have out of Zoom where we're trying to record things. Not record the video, I mean, write notes.
Like write down.
Yeah. And then the last thing I'll say is if anyone has comments about how today went, we tried to adapt things and it was pretty experimental, but if you have feedback or thoughts, reflect on it, send us notes. we'd love to hear it.
There's a
Thank you
feedback
all.
channel on Slack, so if you want to post anything there, you can.
That note, thank you all, and especially our moderators today who did a fantastic job.
Yes, let's all thank Ting and Guillaume.
Yeah.
Thanks all.
Applause number 7.
Applause
Good.
number 7.
Okay, thanks everyone. We'll see you tomorrow and on Slack.